In this video, we're going to be doing more examples of how to graph lines. So in particular, just given a line like this, how can we find the equation for this? So this is going to be y equals and something. In this video, we're going to try to figure out what that is. And before we get to that, we're going to talk about something called the slope. So what the slope gives us is a measurement of how kind of steep this line is. So how much is it going up? So moving from left to right, how much is it moving up? Or for example, here's another line, how much can this line be moving downwards as we move from left to right? So this one's moving up, this one's moving down. The slope is going to give us a measurement of that. And there's three ways, let's say two ways to sort of view what the slope means. So suppose we're given 2 points. Let's draw another graph. So we still have one line on it. So here's 2 points on this line. We'll call this point x1, y1, and this is x2, y2. Okay, so we're given these 2 points. One way we can think of the slope, and also the slope is always denoted by this little letter m. So usually in math, this m means slope. And so say if we're just given 2 points, we can find the slope by this formula. y1 minus y2 over x1 minus x2. And sometimes you'll see other books, it's different. It says y2 minus y1, x2 minus x1. That doesn't matter. As long as there's one here, and a 2 here, and a 2 here, like they're the same number, that's fine. So you can put the 2 here, the 2 here, the 1 here, and the 1 here. But this formula is just the same as any other formula you would find online. So this is one way to view the slope. This is just if you're given 2 points. Another way to think about this is rise over run. And what this means is, so here's these 2 points. The rise over run, it means how much we go upwards, so this distance, and then how much we run, meaning we go to the left or to the right. So this can be this distance. So if you see, that's what this number is here, y2 minus y1. So y2 minus y1, that's going to be this distance right here. That's the rise. And then x1 minus x2, that's going to give us this distance right here. So that would be the run. So that's another way of thinking the slope. Either if you have 2 points, you could do it like this. But graphically, this is what it means. How much we go up or down divided by how much we go to the left or to the right. So just a quick example. Say if we had the points 1, 3 and minus 7, 5. And then we want to find the slope between these 2 points. So we can call this is the point y1, or sorry, x1, y1, x2, y2. And then we just plug everything into this formula over here. So m equals, we're going to do y1 minus y2, so 3 minus 5, divided by x1 minus x2, 1 minus a negative 7. Okay, so 3 minus 5, that's minus 2. 1 minus a negative 7, that's 8. So this is going to be minus 1 over 4. So the slope between these 2 points is minus 1 over 4. Okay, so before we, again, get into graphing anything, one other thing we're going to talk about is what does it mean for a line to be parallel and then perpendicular. So parallel and perpendicular. So just with the graph, parallel with a picture, what it means is the 2 lines are moving in exactly the same direction, something like this. So they're never going to cross each other. They're just, this one's moving this way, this one's moving the same exact, so you can say they have the same slope. So this one goes up and over the same way this one goes up and over. And then perpendicular, it means, so for example, say if we have this line right here, a perpendicular line crosses this, and then this angle right here has to be a right angle. And so what these what 2 lines mean, so say here's these 2 lines. These 2 lines are parallel, and that means that they have the same slope. So if you have parallel lines, they have the same slope. And if you have perpendicular lines, this means that they have negative reciprocal slopes. So for example, suppose we have a slope of 7. the parallel slope is also going to be 7. So if you have a slope of 7 and you want to find the slope of a line parallel to this, parallel means same slope. So if our slope is 7, the parallel slope is also going to be 7. So over here, just another quick example. Suppose we have something like one line has a slope of, let's say, negative 2/3. So what this negative reciprocal thing means, to find our perpendicular slope, the negative reciprocal means is the first thing you're going to do is just write down a minus sign. And then what we can do, let's put a parenthesis. And now the reciprocal means we're going to take our old slope, this minus 2/3, and then just turn it upside down. So instead of writing minus 2/3, we're going to write minus 3/2. So here these minuses cancel, and we're just left with 3/2. So let's do a couple more examples just for perpendicular. The parallel one's easy. Just parallel means whatever your old slope is, the new slope's going to be exactly the same. Let's do some more. So suppose we have a couple of slopes. Let's start with this one. M is just 3. And we want to find the perpendicular slope. So the perpendicular slope is a negative reciprocal. So negative just means the first thing we do is write down a minus sign. Let's put a parenthesis. And now reciprocal. So reciprocal means we take our old slope and just turn it upside down. So we already did the negative. So we put our negative sign, and then we do the reciprocal. We take the old one and turn it upside down. So instead of writing 3, we're going to write a 1/3. So this is going to be negative 1/3. Okay, so let's do the same thing now with, how about m equals 1/2. So the perpendicular slope, again, negative reciprocal. So negative means it's put a minus sign. And now we're going to turn our old slope upside down. So instead of 1/2, it's going to be 2/1. But 2/1, that just means 2. So this is going to be negative 2. And then the last one, let's do, how about 7/5? So the perpendicular slope for this one, again, just put a minus sign and have the old one and turn it upside down. So instead of 7/5, we're going to have 5/7. So we get minus 5/7. Okay, so that's just basically what it means. And again, so say if this is the perpendicular slope, is minus 1/3. Let's just do this one for example. So the parallel slope, which is just the same thing, the parallel slope is 3. So the parallel slope for this one would be 1/2. And the parallel slope for this one would be 7/5. It's just the same thing as whatever slope you're given to you. Okay, so let's do a couple of questions of how we can find equations of lines. So this first example, suppose we have a line passes through the points -2, 7 and 110. So we want to find the equation of this, the equation of a line that passes through these 2 points. So before we start this, one thing we need to know, so what is the equation of the line? So before we do this, the equation of the line is this. Y equals mx plus b. So this is also called slope-intercept form. And the reason why that's called that is this b right here is the y-intercept. And this is the same, the y-intercept from the last video. And this m right here is the slope. So what's mainly important for this section, since we're not going to really be graphing, we're only going to be finding the equations, is just this equation right here, the slope-intercept form equation. So in all of these problems it says, find an equation of the line that does this, or find an equation of the line, passes through these 2 points, or so on. When we want to find an equation of the line, the first thing we want is, well, we want this. We want y equals mx plus b. Okay, so just, that's like a big part of this problem, is this, well, we want an equation of a line. So here's the equation of a line. Then we got to say, okay, so what part of this do we not know? So the only parts of this we don't know are what is this m and what is this b. So, but we know what they mean. This m is the slope and this b is the y-intercept. So what we need to do then is find the slope of this line and find the y-intercept of this line. And all we are given is these 2 points. But we remember on the previous page we had the slope equation, and the slope equation only required 2 points. So we can find the slope of this line. So we can find our m just by using these 2 points. So remember, the slope equation is y1 minus y2 over x1 minus x2. And we're given these 2 points, minus 2, 7, and 110. Okay, so we can just plug these points into this equation. So we're going to do y1 minus y2, so 7 minus 10, x1 minus x2, so minus 2 minus 1. So 7 minus 10 is minus 3, minus 2 minus 1 is minus 3, and this is going to equal 1. So now we found our slope. Our slope m is equal to 1. So now we can rewrite this equation. Instead of y equals mx plus b, we can just have this equal to y equals 1 times x plus b. But 1 times x is just x, so this is just the same thing as y equals x plus b. So now we're closer to our answer. We found what our m was. Our m is 1, but now we just need to find what this b is. And the easiest way to find what this b is we're going to take either one of these points. It doesn't matter which one you choose. Let's say we choose this, the first one, minus 2, 7. So we're going to take this point, minus 2, 7, and we're going to plug it into this equation. Remember, so this minus 2, that's an x value, and this 7 is a y value. So we're going to take these two numbers and plug it into this equation and then solve for b. So y is 7, so we're going to get 7 equals, here's x, our x is minus 2 plus b. And this is easy to solve for b, we just have to add the 2 over. So we get 9 is equal to b. So now we have everything we need. We know that our m was 1 and our b is 9, so we're just going to plug everything back in. So we're going to get y is equal to 1 times x plus 9. So here, this m is 1, we found that a second ago, and the b is 9. So we're going to plug a 1 right here and then a 9 right here. And so this would be the answer. This is the equation of the line that, so if we have a line that passes through these 2 points, the equation of that line is going to be this right here. Okay, let's do the next example. So now what we want to do is find the equation of a line. So a line that passes through the point 2 minus 5 and is perpendicular to y is equal to minus 1/2 x plus 16. Okay, so if we look at the previous problem, this is a little bit different from this one, but we still want to find the same thing. We want to find an equation of a line that passes through this point and is perpendicular to this. The important thing is we want to find the equation of a line. So that means we want to find this. Y is equal to mx plus b. Okay, so just like before, we need to find 2 things. We need to find our m and we need to find our b. Well, we only have 1 point this time, so we're not going to be able to use the slope formula, like last problem where we had 2 points, we plug them into the slope formula. But what we do know is our line is perpendicular to this line. And we know how to find the slope that's perpendicular to this line. So first we're going to look at this line right here. So notice that this line's already in y equals mx plus b form. Here's y is equal to, here's your m, x plus your b. And then also we know that this number right here, the number attached to x, that's the slope. So this number right here, this is the slope of this line. And say if we want to find the perpendicular slope, so this means that the perpendicular slope equals, okay, so we did this on the previous page. We know our slope of this line, we're perpendicular to this line. So the slope of this line is minus 1/2, so we have to find the perpendicular slope. So when we find the perpendicular slope, the first thing we do is put a minus sign, put parentheses, and we take our old slope and turn it upside down. So instead of minus 1 over 2, it's going to be minus 2 over 1. So what does this equal? Well, these minuses are going to cancel, and we're at 2 divided by 1, which is just 2. So the slope that's perpendicular to this line is going to be positive 2. So then we can replace this m with 2. So y is equal to 2x plus b. Okay, so now we need to find what b is. Before we had 2 points to choose from to plug in here. Now we only have 1 point to choose from. So that doesn't matter. We'll just take this 1 point, plug it in here, So 2 minus 5. Here's your x and your y. We're going to plug it in here. So y is minus 5. So we're going to get minus 5 is equal to 2. X is 2 plus b. So minus 5 is equal to 4 plus b. Subtract the 4 over. Minus 9 is equal to b. So now what we can do is take this equation up here. We found that our m was 2, so we're going to get 2x, and our b is minus 9. And so for this line, this is going to be the equation. Okay, so for the last example, what we want to do is something similar. So a line that passes through seven, 3 and is parallel to 2x plus 2y is equal to 18. Okay, so again, this is now sort of similar to the last one, except before we wanted to find an equation of a line that was parallel to a given line, perpendicular, but now we want to find an equation of a line that passes through this point and is parallel to a given line. But what was different was before is the line that we were given in the previous problem was already in the y. Let's write that down. So y equals mx plus b. Again, this is what we want, the equation of a line. But the thing that was different from the previous problem is the original equation given to us in the previous problem was already in this form. So we knew that the number just attached to the x was the slope. In this situation, this isn't of this form. So in order to find the slope of this line, we need to manipulate this to look like this. So we need to get y equal to mx plus b. So we need to get y alone on one side and everything else on the other side. So to do that, let's get the y alone. So here we have this 2x. We can move that over to the right. So this is going to be 2y is equal to minus 2x plus 18. And now, again, this is almost there, but y has to be alone. Here we have a 2 attached to the y. So let's divide everything in this problem by 2. And then we're going to 2's cancel, so we have y. These 2's cancel, so we're going to have minus x, and then plus 9. Okay, so now what we want is a line. Just remember these. So these are the lines right here. This is all the same thing. So this line right here, that's the same thing as this line right here. All we did is just manipulate this to turn this into y equals mx plus b form. So what we want is a line that passes through this point and is parallel to this line, meaning parallel to this line. Well, parallel means same slope. This number attached to the x, because now we're in y equals mx plus b form, this number is the slope. So minus 1 is the slope at this line. But this tells us that the parallel slope also equals minus 1. Remember, parallel slope is the same. So the slope of our line is going to be minus 1. So we're going to rewrite this. Just y equals minus x plus b. Because we're doing minus 1 times x, so that's minus x. Okay, now just like before, we have one point to choose from. We're going to take our point and plug it into this line. Here's our x value, here's our y value. We're going to plug it in. So y is 3. We're going to get 3 is equal to minus. X is 7. And then plus b. So 3 is equal to minus 7 plus b. We add this 7 over, and then we're going to get 10 is equal to b. So now we know our m is minus 1. So again, just y equals minus x, because we're plugging a minus 1 in for m. And our b is positive 10, so plus 10. And so this would be the equation for this line.